friends, welcome to Insults. Today we're going to see some in a universal sandbox. So by the way, this is the 90th episode of Space series. So you may wonder, why are we in a game in the space series? So up to now we have seen everything on a board, where we learned almost everything in space series, up to what we discussed. But now we're going to do some practical work. Practical means here. Okay, so first let's just see the road limit. And also this game is very good. It's less like a game and more like a simulation, but still it's wonderful. You can turn on the habitable zone of a star. You can make your own stars, which I kind of made, and your own systems. These are everything I made. Okay, so let's just take one small look at the Earth. Can pause time, thank you. So let's just go into here, zoom in. We are here. Look at this detail. We can literally land on this thing. Wait, see, we are in the ocean, but escape the ocean. So this is how this game practically works. You can literally throw objects. Let's just know the habitable zone. So let's just make a new empty simulation to show things. So first we're going to discuss and see about the roach limit. A limit where when there's a big thing, when another small thing comes into that big thing's roach limit, then that small thing will absolutely be destroyed into pieces. So for this example, let's take over very one or two few pairs in a while because there's no sunlight. Look at the ice quickly growing. But that's not what we need. We don't need life here, because it is going to be ended in a brutal but still way. Let's take a random move. Let's take tuna safe. It sounds kind of sci-fi. So now, at this point, it's perfectly orbiting around the Earth. But now, closer. Just much more closer. Just 10,000 kilometers. Look at that, it gets absolutely shredded into pieces and pieces. It's not completely destroyed. And also, let's keep Earth ocean. Zero velocity. Position lock on. Stay there. So, see, that small moon thing, Tuna's side, the closer one, got absolutely obliterated. There will be smaller fragments still orbited around. Wait, this is center. That is Tuna's. These are different. So if the moon's mass is kind of reduced, that means it could kind of theoretically happen. But you know, this is a simulation and everything is not correct. Here it just gives it, the roach limit is decreased because the planet is much more smaller, this moon, and it is held by its gravity by itself. And now the Earth and its tiny new moon, and the Earth is absolutely destroyed by the... Wait, I have an idea. Let's make the Earth cool down. So my god. And that's the Earth. So now let's make a new simulation to see about another thing. This thing is the one and only brown dwarfs. So we already discussed that brown dwarfs are pretty massive. They have about 80 masses of Jupiter, which is quite a lot. So let's take Jupiter, and now let's take it. Go to so mass is 80. Let us hit it. Now it's a star. So if the mass of an object, a gaseous object, is more than 80 times of Jupiter, then it will become a star. A small mistake on my behalf. So if the mass of an object, a gaseous object that is about 13 times more than Jupiter, then it is a brown dwarf. It's exactly 13, so let's make it 14. Can you please start heating up? Yeah, it's shrinking kind of. Can you please do just yeah, look at that. That's a brown dwarf. Here is our guy, Jupiter the brown dwarf. So now this thing is a brown dwarf, Jupiter. And also, so this star, the Jupiter star which I made here, which I made by adding 80 plus Jupiters together. Okay, so right. Okay, so that is for this. Let's go to new empty simulation G. So now we're going to discuss why did the moon get shot away. Okay, so yeah, so let's take a random star. Let's make it go supernova. This is also another star which I made. And why is it increasing in size? G. G. So now we're going to see the habitable zone of a star. So first let's take Earth, the one and only Earth. So this is so let's take 3 Earths, not one. Just pause it. One in the hot zone, one in the habitable zone, and one in the cold outer ring. Let's begin. Wait. Okay. So next, let's just observe them for some hours. So this is the orbit system. Okay. So after a few months, after the simulation started, after a few years to be specific now, we pause the simulation. Let's go at this Earth. We can just fly to it. So this Earth, let's see at the surface, it's very hot. 277 degrees Celsius. Let's just put it to Kelvin. 551 Kelvin, which is pretty hot. And even the poles are so hot. They are 363 Kelvin, which is 90 Celsius, which is pretty hot, but still kind of bearable. But that's for the poles. If it is a desert, that's okay. But that's the literal poles. So next, let's look at the one and only, the habitable Earth. So shift. So now let's go to this Earth and just fly to it. See it. It has life. It's perfect. The surface is perfect. There are places at negative 51.7 degrees Celsius, but that's still just common on Earth. It's kind of cooler because I kind of placed at a different location, but still there's life on it. Let's look at the composition. Go down. There's Earth similarity 88. Yeah, because it's kind of away in orbit, but life likelihood 90%, and there is life. That's great. And last and finally, let's look at the last planet, the last Earth. This is in the cool range. It's completely ice. The surface temperature, the hottest temperature is literally negative 1.4, and the coolest negative 1.3. That's pretty cool. Let's just go down here. Wait, it's in the composition. Let's see the life likelihood. There's still 93.5 likelihood because I didn't place it too far out. That's my problem. Sorry on my behalf again. So now I just told you before we placed all these Earths that we're going to see a supernova. So simulation because we need some space, Okay, G and O. So tools, add one. Let's add a star. Random known star. I want any star, a pulsar. So next, can you please stop? Next, in binary action, Control Z. Let's just start them again. Okay, still, and another still one. Wait, I'll just slow it down. What is happening? Okay, let's take a big star. I don't want a kilonova. This is the largest star in existence. Stephenson 118 and another Stephenson 118. So now let them collide. Okay, let's launch one Stephenson 118 and another Stephenson 118. Oh my god. It will take a while for this to render because I'm on a laptop, not a PC. It's so slow. Okay. Simulation can't run any faster with current settings. I understand everything, game. Where is the Stephenson 118 by the way? Where are you? And that's just supernova for now. I don't want to do something much more larger. I want to zoom out. Please let me move. Why is everything white? I'm scared. Oh my god. No, okay, because I had it equipped. Look at the crowd. Look at this, it's so mesmerizing. So this is just a simulation. There are no Stephenson 218s ever. Let's just go. Oh, click home. And okay, so yeah, this for today about seeing some practical stuff in Universal Sandbox. Even if it's 3 things, it's still kind of important. Can you please let me move outside? I don't want to be in a personal zone. Can this please happen a lot faster? It's 4 months per second. Okay, thank you.